This is part 3 of the electrolysis topic in GCSE AQA Chemistry. It's a dual and triple award topic. In this particular video, we're going to focus exclusively on the extraction of aluminium using the process of electrolysis. So we need to know why we extract aluminium and other metals with electrolysis rather than by reducing with carbon. We need to explain how aluminium is extracted from its ore, and we need to be able to show the half equations that go with it, along with a number of important considerations that are making in the industrial extraction of aluminium. So it's a research task, and I'm going to recommend that you try to find as much information as you can about each of the boxes on here, and I will review those once you've paused and had a go for yourself. So let's begin with aluminium ore. We need to explain what an ore is, find out what aluminium ore is called, and know what we need to do to that ore before electrolysis can take place. Well, we spoke in the previous chapter about an ore being a substance that contains enough metal to be economically worth extracting. It contains metal and we need to get the metal out of it. Now, electrolysis is a very expensive process. You're not going to do this when there are trace amounts of aluminium present. The ore that we get aluminium from is called bauxite. Now, that contains aluminium oxide, which the aluminium is extracted from, but it also contains a great deal of other rocky impurities. Before electrolysis can take place, we really need to remove all of those impurities so that we are electrolysing the aluminium oxide. Okay? Moving on to the next box, why do we not just use carbon to reduce aluminium oxide to aluminium? Well, as discussed in the previous chapter, carbon can only be used to extract metals that are below it in the reactivity series. Carbon essentially displaces those metals. Aluminium is higher in the reactivity series, so we can't use carbon to extract it. We then have a diagram of aluminium extraction, and there's a chance to annotate it with some key details. So we have got the carbon cathode, and the aluminium ions, positive, are going to be attracted to those negative electrodes, or that negative electrode. The anodes, made of graphite, which is carbon, are going to attract the oxide ions. And we have got here molten cryolite. The aluminium oxide is dissolved in cryolite to lower the melting point, which lowers the energy costs. And there's a chance to talk about that a little bit further on as well. So the half equations. What's going to happen at the anode? What's going to happen at the cathode? And is it oxidation or reduction? Well, we know that O2 minus, negative, is attracted to the positive anode, and we know that positive aluminium ions will be attracted to the cathode. We also know that we're going to make the elements when we separate these ionic compounds, when we break them down. So we're going to get aluminium, and we're going to get oxygen, which is a diatomic molecule, so we're going to get O2. I'm now going to balance the equations where they're needed. I need 2 O2 minuses to make O2. And finally, to finish my half equations, I'm going to balance the charges by adding electrons. Doing aluminium first, Al plus 3, I need 3 electrons to reduce that to aluminium. And on the top one, because I've got 4 minus on the left and 0 on the right, I need 4 electrons to be lost from 2O2 minus to make O2. And the top one, because we're losing electrons, is oxidation. Oxidation always happens at the anode, and reduction is happening at the cathode. The aluminium ions have gained electrons to become aluminium. And to finish off, we've got a number of things to think about here. So let's start with the key expenses. This is a very expensive process. We have got very high energy costs that we are going to need to pay in to get the aluminium oxide molten, to actually get it to the very high temperatures that are needed. But we've also got the electricity costs as well. There's a huge amount of electricity involved in electrolysing aluminium oxide. Moving on, let's look at cryolite. Now, we mentioned this earlier on the annotated diagram. The aluminium oxide will dissolve in cryolite, and cryolite has a lower melting point than aluminium oxide, so we're essentially using it as a solvent. Now, if we're able to do this at a lower temperature, it means that the energy costs overall are lowered. It's going to make it a more profitable process. And finally, how the carbon anodes add to the expense. So the carbon anodes, they're made of graphite. They are pure carbon. The equation that I'm showing here is what happens at that electrode. We're making oxygen gas. The oxygen gas at very high temperature will react with the carbon anode, and that means we're going to burn that carbon anode away, and so we have to regularly replace them. So we've got the additional costs of replacing those electrodes. That takes us to the end of this video. Thank you for listening, and goodbye.